Hello everyone. Thank you so much for joining this session. This is A.N.K. Zaman and I'm going to present our paper. The title is Ransomware Detection and Classification Using Machine Learning. So first of all, what is ransomware? So ransomware is a malware and it locks a victim's data or device and demands a ransom to unlock it, or worse. Now, what are the consequences? If victim does not pay ransom to the attacker, then that device may not be unlocked forever, or in worst cases, data could be leaked and it has further consequences. So we understand ransomware poses a cybersecurity threat, causing considerable damage to communication structure, servers, mobile and web applications across various industries and businesses. According to IBM, in the year 2022, 70% cyber attacks are marked as ransomware attack. So ransomware attacks are an active area of work, and detecting and classifying ransomware by cybersecurity professionals is a very important task to perform safeguard against any digital assaults. In this research work, we used XGBoost and random forest algorithms for classifying and detecting ransomware. And XGBoost and random forest both are supervised machine learning algorithms, and they are used for classification and regression. But for our research, we used both algorithms for classification tasks. So for our research, we used a ransomware dataset that's freely available through Kaggle. And in that dataset, there are little more than 62,000 unique rows or data values there with 18 features. Out of those 62,000 data, around 27,000 are legitimate collections and around 35,000 are malicious collections. So at the right side, you can see the metadata of the selected data are presented. So we can see all the rows and their type listed in this figure 1. So in experimental setup, so we did a data split 80 to 20%. So 80% data is used for training the model and 20% it used for as a testing data. Now, model training, XGBoost and random forest classifiers are trained using the scikit-learn Python library. So we used scikit-learn Python library to use those models. And both algorithms construct a chain of decision trees, and with each succeeding tree attempting to fix the flaws of prior trees. That's how they improve the classification efficiency. So let's move forward. And for model evaluations, you use following tools to evaluate our models. We have our accuracy scores, precision recall, values, and F1 scores for both algorithms. So let's quickly look at the definitions of those accuracy models. So precision recall, precision is defined as the ratio of true positive to the sum of the true positive and false positive false positive. Recall is defined as the ratio of true positive to the sum of the true positive and false negative. An F1 score is the harmonic mean of precision and recall and provides a single metric that balances both measures. And we can see the equation 3 for F1 score as well. So this is our experimental results, and we can see XGBoost and Random Forest both showed promising result and above 99%, so 99.6% and 99.7% for Random Forest. And you can see the precision, recall, and F1 scores are supporting these accuracy values. So thus we can say this result is promising. We can also see the experimental results with the precision recall graph for XGBoost and Random Forest, and we can see the lines are touching the 0.1, so it's because it is above 99% accuracy, and it supports our result. We also did the survey of recent works, and we can see here both for Random Forest and couple of other algorithms, that's Markov chain, logistic regression. We can see Random Forest and XGBoost algorithms both showed promising result for our experiment, and you can see the higher accuracy for both the algorithms compared to the other algorithms for the recently published work. And our result is 99.6 in case of XGBoost and 99.7% for in case of Random Forest algorithm. So in conclusion, both XGBoost and Random Forest algorithm showed promising results to classify legitimate and ransomware data. And in future, our plan to test those data with CNN-based algorithms. Also, the dataset we used in this case is quite big, 62 above 62,000 rows in that dataset. But we are expecting to run the experiment with the same algorithm and CNN-based algorithm for larger available datasets. So thank you so much for listening us. Please forward your question to any of the authors or to the following email. So thank you so much again. You have a wonderful day.